In this episode, I'm going to look at switch. It seems that it's a useless block, but it is very useful in complex system simulation. For example, if you want to have a system that in the first 20 seconds special signal enters the system, enters to the system, and in the next 20 seconds another signal enters, you can use this block. I added to my new model in order to explain it more. This block has 3 inputs. First 2 signals are the ones which will be transferred to out. But the middle input is a criteria for passing the 2 other inputs. With this input, we indicate that which inputs transfer to the output. I double click on the block to see its specification. As the other blocks in the Simulink, you can see the switch block information here. It is said that pass through one input when input 2 satisfies the selected criteria. For example, here we set the threshold to, I set its condition as the second input be greater than or equal the threshold. If it be greater than threshold, it uses input 1, and if it be smaller than threshold, for example, if it was 1, input 3 will be applied for output. Here, as you can see, we can set the second input in 3 ways. Here I will do 2 simulations. One is time dependent. In time dependent, for example, we want to have a 100-second simulation with, in first 30 seconds, the third input applied and the first input applied from 30 to 100 seconds. I will teach you to have such a system in the second example. In the first example, we use a very simple block like sinus and constant blocks. Sinus and constant block. In doing so, I add block to new window. I want to allocate 2 sinus inputs to first and third inputs. I want to allocate 2 sinus inputs to first and third inputs. I set the constant block 75. I set the threshold value 75 too. I use display to see the output. I transfer the sinus block to switch. In the sinus block, I set the sinus amplitude and frequency 1, and also set the sinus bias or DC value 75. I set the phase, which here is radian based minus pi. Here the 2 signals are for comparisons. Given the amounts, the output which come from the switch and show on the display should be based on the first input. Why? Because the threshold amount is 75 and the condition is that U2 be greater or equal, which is equal here. And when it be equal or greater, the first input will be conducted to output. Now you can see the third display is 75, but the other outputs are same. Now for comparisons of these two blocks, we can see that they are started from 75 as the bias value was 75, and one of them has minus pi shift phase to another signal. Again, I want to save the model, but here we have error. Here the error is that we have a switch file in our system, so in MATLAB, and we cannot save another file as switch. So I save it as switch 1. I close the model and finish this switch section. I keep working on common blocks. Here I want to explain some which has been used in previous chapters. I click on the block. You can change its shape. You can increase the number of signals. Also, the block can perform minus operations too. You can add them to block with adding minus here. In round shape, the straight line indicates in what angle that positive sign shown, and you become able to enter the signals related to this block from that angle. I set the rectangle shape here. This block has numerous applications in simulation. I want to give an example here too. The sum block, just like product and gain, is not limited to scalar and constant data, but you can use complex numbers, matrix, or any other data and do the subtract or addition by sum. Okay, let's give an example. That this example has matrix addition and subtraction from and the numbers, the subtraction form and the numbers of the matrix are the complex numbers. It means both matrix and complex numbers are considered here. In this example, I want to show a plus b minus c. So I need 3 inputs. I use 3 constant blocks to enter the numbers. Also, I use a display block for showing the output, because I want to have a matrix output. Okay, first I change their names. A, B, C, as you can see like this. Now in A, I enter the matrix value. As you can see, it is a 3 times 3 matrix. I'm going to have such matrix. Now, as you can see, it is a 3 times 3 matrix. There are 3 rows and 3 columns. The data have been defined as complex numbers. And here we should define other matrices. So as we want to have multiplication operation, I enter the values here. I do so for block C, Now we can make sure from the multiplication and addition of matrices, because we made 3 matrices which they are same in rows and columns. Here you can see the result of math operation and then analyze it. So here, as you saw, we can make sure from the math operation by using this block. I save this block, and if you wanted, you can run it later. The other block, in commonly used block, is relational. I add it to my new model in order to show its application. It is a conditional block because there is a condition between 2 inputs. If the condition fulfilled, the window, then it shows the output. By double click, you can see the data of block. The operators are seen here. One of them is equality, in which the output will be gotten if the inputs be equal. We have approximately equal, less, greater than of, equal to, and others. Here, for example, if we consider less than condition, it means that the first input should be less than second input. Here I want to have simulation using the equal condition in order to know its applications. I want to compare determinants of 2 matrices. Then if they were equal, the output shows 1, and if they were not, the output be 0. We use that instruction in order to show matrix determinant in constant block. Here, if I add A, it means that I need determinant of matrix A. Here also you can enter the matrix, but I used its name for this block. I want to get the determinant of matrix B. Then in the relational block, the determinant will be compared, and if they were equal, it will show the intended output, which is 1. I define both matrices in model properties. And matrix B 2 1 2 3 0 1 5 1 and 0. I run the model, and as we can see, the output is shown 0, which means the determinant of the two matrices were not equal. You can enter other matrices and use this block in your simulations. Here I save this block for you to use it in case of need. As I saved it as rotational. Okay. The other block I want to explain is logical operator, which is related to logical circuits such as and or x. I add it to my new model. We have this block in logic and its operation section. Because I don't want to explain this library, I want to explain this block with an example here. You can see the data of this block by double clicking on it. Here you can change the functional mode. Also you can here you see the nodes and other functions and other modes. Also you can increase the inputs. My example here is I want to get a D which equals A times B plus C. The A is 1, B 0, and C 1. I add constant block to my new model. I here define the names as A and B. In the logical circuits, we define the A, B with AND operation, and for some we use OR operation. I change it to C and connect them to each other. Here also I add a display block, sinks and display. I add it to the model. Connect them here. I connect it here. Here. I set the values As we know about logical circuits, we expect the 1 0 and becomes 0 and 1 0 or becomes 1. In the first display, which is about, and the output is 0, and in the second, the second one, the output is 1. As you saw, logical circuit operators can be simulated simply, even if they be very complex and tough. Save it. Okay, the last block which I'm going to explain is data type conversion. This block can change data into different types. Generally, there are two classifications of signals. The first one are those, first ones are those which we call them in MATLAB and Simulink. The second type are the signals that just designed for MATLAB and you can't use them in Simulink. The Simulink usually the Simulink supports most of the signals related to MATLAB, except a few signals like Unit 64 that they are for special applications. Here you can see the signals that you can recall them in the Simulink, like double, single, unit 8, 16, 32, and Boolean signals that are related to logical circuits, and the other signals that you can see here. You can use this block to convert the type of the input signal to desired signal. I think this block is for specific projects and is not common a lot, and you can use it for special applications like when you want to change the data type. Okay, it was the last block in commonly used blocks. We will explain other libraries later. Here we have subsystem block, but I want to explain it in subsystem episode. I don't want to use it here because its generation in models is very easy.